this particular problem over here. So point moves rectilinearly in one direction. Okay, so this is basically the displacement versus time curve. So okay, so over here the maximum time for which it goes is 20 seconds. Distance has traversed as a function of, yeah. So using the plot, find the average velocity of the point during the time of motion. Okay, so this one is fairly simple. So so average velocity, V average, is basically total distance divided by the total time taken. So I mean total displacement by the total time taken, and the total time taken over here, max up to which we are considering, basically 20 seconds, and the distance displacement is 2 meters. If we convert it into centimeters, is 200 centimeters per second. So this becomes 10. Sorry, so this is 10 centimeter per second. Okay, very good. First part is solved. Second part, the maximum velocity. Okay, so maximum velocity is basically, and velocity, whenever we are seeing the velocity, so velocity is basically the instantaneous velocity, or v instantaneous is equal to ds by dt at that point. I mean, it's a v instantaneous at some t equal to t naught. So this is ds by dt at t equal to t naught. That's what it is. So essentially, if you see the curve, and the instantaneous velocity is basically the gradient. So wherever you have the maximum gradient, there you have the maximum velocity. So where do you have the maximum gradient? It is, so yeah, it is in this part. Yeah, it's in this part basically that you have the maximum gradient. Before this and after this, the gradient is smaller. All right, so this you can easily calculate. So you see, this is divided into 5 blocks of 10 by 5. Each block is 2 basically. This is basically 10, 12, 14, 16, 18 and 20, right? And you see, this is, so over here on the y-axis, 1 2 3 4 5 blocks correspond to 1. All right, so maximum velocity, the gradient is nothing but, since this is a straight line, we can say that it is basically this upon this height upon this base of this right angle triangle. This height is nothing but 1 2 3 4 5 blocks. 1 2 3 4, yeah. So it becomes basically, the height is 1 meter, and the base is 14 minus 10, 4 seconds. So your maximum velocity is basically, so again in centimeter per second, 1 meter is 100 centimeters divided by 4 seconds, centimeter per second, that becomes 25 centimeter per second. All right, so we have done the first two parts. Now for the C part, the time moment t naught at which the instantaneous velocity is equal to the mean velocity averaged over the first t naught seconds. Okay, so basically, at what point of, or at what time instant is the instantaneous velocity equal to the average velocity? Now, if we consider any random point, I'll just take any random point. Let's say I take this point. I consider this point. All right, just a random point. So over here, my instantaneous velocity is basically, So it will be rough. It's basically instantaneous velocity is the gradient, right? Basically, if we consider the tangent over here, yes, so it's basically this theta, then this tan theta is basically the instantaneous velocity. And what is the average velocity? Average velocity is very simple. It is till that t naught, the total displacement by total time. And what is the displacement? So I'll use another color. Or the displacement is basically the y, this thing, divided by the time, which is this, right? So basically, if I take this point, so it's basically the gradient of the line joining the origin at that point. So basically, to recap, instantaneous velocity is the slope at a given point, and average velocity is the slope of the line that joins that point and the origin. So when would these two be equal? Only when the tangent at a point of the curve is passes through the origin. Only then both of them basically will be equal, right? Okay, so now to find it out directly, because we do not know what is the equation of the curve and all, we have no idea. So what we need to do is we need to, I mean, as far as, yeah, so basically we need to basically take some sort of a scale, right, in order to like roughly see wherever you have like the highest tendency. See, after all, we can only measure things at these, wherever these grid, basically points on the grid. So if we consider, let's divide the curve into three parts. I mean, let's say we do not have any scale, anything. How will we just solve this? So let's say we divide it into three parts. First part is where like the non-linear part of the curve, which is this, and the linear part. Then again, basically, I should have taken. All right, it's fine. Then maybe this part. All right, till 20. So if we consider any point on this, so since it is non-linear, obviously, and yeah, so since it is non-linear, basically the obviously the point, the instantaneous and average velocities, basically the slopes won't match, right? If we consider any point over here on in the second part, also it won't match, because the instantaneous velocity is basically the slope of this line, which does not pass through the origin. That is also cancelled out. Now we can only hope that somewhere over here in this part, somewhere the tangent passes through the origin. All right, now we can see, obviously, so over here also it's still from 14 to, so from 16 it starts to, so from 14 itself the slope starts to decrease. All right, so we just need to see, like 14 can't be the point because it's the linear part. It could be either 16, it can't be 20 because 20 it's the slope becomes 0, which does not pass through origin, obviously. So it could be either 16 or 18, given the limited information that we have. Now 18, as you can see, it is very highly unlikely that it would be 18, right? Because roughly it goes this way, right? But I'll change the color. For 16, which is this, sorry, it's almost that it goes through the origin. So I'm not drawn it to scale, obviously, because I don't have one right now. But yeah, so by a little intuition and by basically elimination, we can, and given the limited information that we have, basically we can say that for t naught equal to 16 seconds, the slope of the line joining the point and the origin, slope of the line joining the point and the origin coincides with the tangent to the curve at that point. So which means that the average velocity matches with the instantaneous velocity. So this is the C part. So yeah, thank you.